This is my short lecture about covalent bonds. It is prepared for my curriculum instruction master course project. Okay guys, we are studying today covalent bonds, which is a new chapter. About the covalent bonds, we're going to learn how we define the molecules and covalent bonding and octet rules. First of all, in order to understand, to get some curious about the topic, I would like to give you some small video about this. Are you ready?
Yes.
Thank you.
So this video is a bit weird. I've got some new software I'm trying out. Now both of these big tough guys, they like to shake hands. And since they're both as strong as one another, the handshake's going to be right in the middle. Not to the left or to the right. It's going to be a symmetrical handshake. No one's pulling harder than the other. Now these two guys here, again, they're sharing a symmetrical experience. Both of them are enjoy it as much as the other. So it's going to end up in the middle of their activity. But when you put them together, the big guy, well, he's so much stronger, he's going to pull the handshake over towards himself. So let's look at the word covalent.
We call this covalent.
Co means together.
Together.
And valent, well, that means valence. And in this case, the valence electrons. Where
Valence
they,
electrons
well, hopefully you remember,
outer shell
the
of
outer
atoms.
shell of an atom. Or maybe I don't know.
You remember that from
You
following
can
course,
also
right?
call that covalent or cohabitation. So that's how you remember the covalent ones are the ones where electrons are shared. Now when these atoms share electrons, in some cases ions, they're going to have 2 or 8 electrons in the valence shell when they're done. This is stable. So if you're only looking at the first shell, that's going to have 2. And if you're looking at other shells, well, they're going to end up having 8 electrons once they've done their sharing to become stable. They'll look just like a noble gas. Now don't get this confused with, I'm listening to a bangarang, that's why everything's moving jerkily. Don't get this confused with ionic. Ionic is where electrons are transferred. We're not doing that, we're doing covalent, co-sharing.
Not ionic. Today we're
These
talking
two
about
atoms close
covalent.
together.
Comes together 2 atoms and shared
And
electrons.
again, when they share their electrons, if they're sharing the first shell, they're going to end up with 2 electrons there, or if they're sharing any other shell, they're going to end up with 8 electrons together in those valence shells I've indicated. And the covalent bond, well, that's going to be the shared electrons between them. So moving on, let's look at some examples. Now remember those 2 big guys, they both love handshaking. That's like chlorine. They both really love electrons. So they're going to have a covalent bond, they're going to share the electrons because they both love electrons. How do I know that? Well, they're both non-metals. That's how you can work that out. The measure of electron love is electronegativity, which will come up a little bit later. Chlorine has a high electronegativity. Now hydrogen, that's like the little guy. Doesn't have a big electronegativity, only lacks electrons a reasonable amount, a lot less than chlorine, but nevertheless the electrons will still be shared equally. If I put hydrogen and chlorine together, well, the chlorine loves electrons more than hydrogen, so it's going to pull those over, but it's still a covalent bond. Electrons are still being shared, if unequally, between those 2 atoms, the hydrogen and the chlorine. You can also get double bonds. This is ethene, you're going to need to learn that, and triple bonds. That is ethine. You'll have to learn that too. And strangely enough, they want you to...
Yeah. As you see, atoms shares electron, not electron transfer. It is not ionic, it is covalent bonds. Okay, let me tell you some about topic right now. I have a PowerPoint. My screen is not good, sorry. How you make bigger the screen? You know, I couldn't find here, some is cap here. Oh my gosh. Okay, here's our objectives: defining molecules and molecule formulas, and state the octet rules. You see, molecular compounds, the atoms comes together and makes molecule. And in order to make it a molecule, they have to give each other electrons or share it. If they share the electrons, it means covalent. If they transfer the electrons, it means ionic. But it is not today our topic. We are talking only today covalent bonds. And molecular compounds formed by covalent bonds mostly. As you hear, water, carbon dioxide, you see here, and it makes this formula because of forming covalent bonds. Formation of covalent bonds. How it makes a covalent bond? The outer shell unshared electrons shared by two atoms at the same time. We call this the octet rule. Outer shell you see here is the chlorine. It has actually 7 A group elements, and it has 7 electrons at the outer shell. One is empty, so it needs one more electron to make an compound. So another chlorine comes together and they share their each 1 electrons together. They make out shell electrons, complete 8 electrons, as you see here. Both has 8 electrons. And also same in hydrogen bromide. Hydrogen is 1 electron, but it needs to be double to have an octet rule. So bromide has 7 electrons. In order to reach the octet rule, needs 1 more electron. So they shares 1 electron from each other. So they reach to S2p6 electronic configuration. Total, bromide has 8 electrons at the outer shell and hydrogen is 2. And as you see the bonding of octet rule, as you see it is showed with electron pairs, as here, fluorine is both only 1 electron outer shell, as you see here. And also lithium and fluorine. Lithium has 3 electrons, 3A group, and fluorine is 7A group, has 1 unshared electrons, so they share each other and make a compound. So that is the whole topic today. Hopefully you understood. Right now I have small quizzes. You can see here at the same time from screen. And also I'd like to give you handouts. Please keep your phone and do it very quick. I'd like to if you understand this topic, okay? We have just 3 minutes for 3 questions. They are very easy, as you see. Determine number of atoms and elements present in molecule. Yeah, good job. Good job. I see most of them you already done. Okay, I'd like to be happy to collect your papers and I'll read them at home and tell you tomorrow, next course, how you did, how is your performance. But so far it looks well. Thank you very much. Okay, almost we have end of the course. Let me put them here. And let's make a wrap-up activity, that the closure to our course today. We have small activity, wrap-up activity. You can see that, right?
Attention Honey Hawks, these are your after-school announcements.
Sorry for announcement.
Seniors, prom tickets are $50 this week. Buy them by Friday at lunch before the price increases.
Here is
Tomorrow
also
is Team Up Against Cancer, aka
in this
Jersey
handout,
Day. It's $2 to buy
your
one
wrap-up
thing. You
activities.
can buy them in
Let's put them
tin or
together,
after
the
school
answers
announcements.
there.
Students, don't forget to pay your lunch balances.
Okay.
Just a reminder,
Draw
if
Lewis
you are
structure
over
of the
$30,
carbon
you
dioxide.
will have an alternate lunch.
How we do it? First,
All host
carbon
members, please
center
report to the front office at
shared
the school.
with
And
two
Christopher Haynes, please
oxygen
report to the front office
the,
at
with a
the
double
front.
bonds, right? Yeah, how we draw it at the center, yeah, as your friend did. Carbon at the center. Very good. That's the correct, yeah, exactly like that. Okay, next one. Draw Lewis structure of hydrogen cyanide. One hydrogen, one carbon, and one nitrogen. As you see, the carbon at the center again, right? Let me check how your friend's doing. No, it is at the carbon at the center, yeah, like this. Very good. And connected to nitrogen one side and hydrogen the other side. Yeah, exactly like this. This is very good. Okay. All you did very well. Thank you very much for this course. If you like to ask me something, you can email me, okay? Thank you very much. Thank you for watching. Don't forget to like it on YouTube.